So, ladies and gentlemen, Hurricane Melissa just made landfall over Jamaica as a Category 5, making it the strongest hurricane ever recorded on record. Let's talk about how Hurricane Melissa actually came to be and why is it the strongest ever recorded. Let's talk about it. So let's talk about the early life forms of a hurricane. So hurricanes form through a powerful combination of warm ocean water, moist air, and unstable atmospheric conditions that set the stage for a rotating storm system. So let's talk about the basics of how hurricanes eventually form. So, simple clouds start off as just you have your ocean, basically your heated ocean. So hurricanes love warm, moist air. So warm ocean water around 80 degrees Fahrenheit or 26.5 degrees Celsius, right? They love that stuff. Anything that's above that, they love it. So eventually it starts off as, you know, evaporation basically, adding moisture and heat to the air above it because once you get above, higher up in the atmosphere, it gets cooler, right? So all the evaporation, these water vapor pretty much as they kind of pretty much rise because heat rises and cold air sinks. So the heat as it rises, it gets colder, so it condensates into clouds, releasing latent heat release, right? This heat causes more air to rise, lowering the surface pressure and drawing in the surrounding air. So, let's also talk about the basics of how the hurricane actually forms of itself, but just in a bigger, broader scale. So, let's just say, like I said, I have my piece of land right here. Right here is my equator, and this is where we're gonna actually get to the Coriolis effect. The Coriolis effect is basically just the rotation of the Earth, depending on which area, if you're north of the equator or you're south of the equator. So basically, in the northern hemisphere, we usually have rotations that are counterclockwise. But if you live on the southern hemisphere, the rotations are clockwise, basically, due to the Coriolis effect. So, eventually, when you have just a simple cloud parcel, right? They all just gravitate towards this low pressure system, right? As they all just gravitate towards this low pressure system, the Coriolis effect due to Earth's rotation has effects on how they are starting to form. So they basically start forming off to the right, and then yeah. So eventually they start that constant rotation. That's how you get your first tropical depression. So Melissa started off as a tropical depression. Eventually, once you get all these little cloud parcels as it's following, gravitating towards that low pressure and the acting force of the Coriolis effect, basically it starts getting bigger and bigger and bigger, and eventually you start having hurricanes because they love that source of warm ocean water as it's gravitating towards that low pressure system. And eventually, over time, that hurricane's starting to form, and now it's that sea level pressure is lowering. So basically, all these air parcels, basically, of these little clouds, they all come together, and they center towards this low. So eventually, like I said, they start forcing it to the right because of the Coriolis effect. And so they pretty much swirl around towards that low. And eventually, as they are doing that, as that hurricane's starting to form, it also picks up a lot of that moisture. And so that air just becomes super saturated enough for that sea level pressure just to decrease enough because that area is so unstable because it's picking up so much of that moisture as it's just rotating because of the Coriolis effect of Earth's rotation. So let's talk about the landfall that Hurricane Melissa did. So Hurricane Melissa roared ashore in southwestern Jamaica over New Hope early Tuesday morning on October 28th as a catastrophic Category 5 hurricane, and it traveled 9 miles per hour north northeast, but its spin was only 185 miles per hour, making it the most destructive, most dangerous hurricane ever recorded. Basically, what we're also seeing is that that hurricane is so massive that the millibars have dropped. That sea level pressure has dropped. And eventually, it went from yesterday being only like 906. See, anything that's like 906, basically, like anything that's in the 900s, I mean, that's bad. That's very low pressure. But anything that's below 900 millibars, that's what we're cooking up right here. So Hurricane Melissa is at 892 millibars, which that's a serious low pressure system that can cause massive destructions, massive wind shear, and cause major catastrophic problems like landslides, heavy rainfall, massive flooding, and just hours before it hit, it was recorded at 892. So, yeah. So now let's understand the future of Melissa. So currently, a Category 5 just slammed into Jamaica as a Category 5, and eventually it's going to start decreasing as it goes over the island, eventually slamming into the eastern half of Cuba and the Hispaniola Islands. And then as a series, as it keeps decreasing, eventually as it gets to like a Category 3, it's going to eventually slam into the eastern part of the Bahamas. Eventually, as it weakens out, it's going to start moving that path away from the east coast of the United States as it's traveling north northeast, basically. So it's going to weaken out and eventually get up to the higher latitudes. So now we're going to do some reflection of what's happening now as Hurricane Melissa is totally devastating Jamaica at the moment as a Category 5. It's slammed about 185 miles per hour. And it's continuously moving very slowly. So it's just moving at like 9 to 10 miles per hour, basically. And the wind speeds of those, like I said, are 185, and it's devastating to see it. Just the amount of destruction, the amount of landslides, just how many casualties is already taken out as it's continuously sweeping through the Caribbean and devastating as the days go on. As you know, Wednesday, Thursday, Friday, eventually as Wednesday goes on, we're going to see Category 3 Hurricane Melissa devastating eastern Cuba and Hispaniola, and eventually as a Category 1 as devastate the eastern part of Bahamas. So basically what we're seeing is just that intensive, you know, trend from 2024 as we looked at Milton being, oh, Milton is so strong, we should add another category. Now we're seeing Melissa just in 185 miles per hour wind speeds. It's just ridiculous. Like Category 5, anything higher than 157 or more, that's devastating enough. And like I said, all that sheer destruction. But unfortunately, like I said, hurricane season is going to be more intense. So next year, we're going to be looking for some more intense hurricane season for 26 as more hurricanes because of warm ocean levels, basically. Well, warm ocean temperatures, basically. Because they love it. Anything that's, like I said, that's above 80 degrees, because we will see pockets of warm ocean water exceeding around 90 degrees or more. And that's perfect fuel to create that unstable atmosphere as that water is evaporating and condensates and forms these clouds. And all these clouds starting to move right because of the Coriolis effect, they center towards that low. Eventually, you start getting more devastating hurricanes because of that pocket of warm waters around that specific area it's forming from. So it's picking up all that moisture, becoming more unstable, and just eventually, like I said, they just downpour it. They just boom. So yes, it's becoming increasingly more dangerous as the hurricane season keeps going on and on and on. So, like I said, it's just due to the amounts of global warming and climate change and all that stuff. And, pretty much just we're predicting basically just that, 2026 is going to be a very strong hurricane season for next year. That's all I got to say.